Hi everybody, this is Paul Bruce with Perfecto. We'll get the webinar started now. So welcome to our session today. We're talking about going beyond shift left, specifically 5 steps to detecting issues earlier in your release cycle. Now before I get started, I want to do a quick set of housekeeping. Number 1, the session will be recorded and you will actually see this as an email that gets sent out to you later on, so you'll have this recording that you can share around with your team as well. And then also, if you notice at the bottom right-hand corner, we've got a couple of Twitter handles, the hashtag BeyondShiftLeft, if you want to tweet us out at hashtag BeyondShiftLeft or at PerfectoMobile. During the session, what we can do is answer your questions in real time, and we'll get back to you after the session if we haven't answered the question as well. So what we'll cover today is a few minutes, if you'll permit me about 5 to 10 minutes, to just kind of level set and talk about a challenge that we see in shift left. And then also we'll spend the bulk of the time showing you, kind of going through the 5 steps and then showing you in practice what that looks like down in the code. And then we'll follow out with a Q&A session at the end. So today, you've got me on the call. My name is Paul Bruce. I'm a developer evangelist here at Perfecto Mobile, and you can tweet me out at Paul S. Bruce. And also on the line, we're fortunate to have Nick Sanjinas. He's one of our systems engineers here, and you can find him at Nick Sanjinas. That's S-A-N-J-I-N-E-S on Twitter. Nick, how are you doing today?
Doing well. How are you?
Good, good. Now Nick just went on a cruise, so he's feeling refreshed and relaxed at this point. All right, so let's get started. The first thing I want to do is say, you know, the culture, the climate of software delivery is changing. Now the mantra is work fast and learn often. So whether you're talking about Agile or continuous delivery or DevOps, those are just a few examples of where technology has really accelerated the pace that we work. And it's really not enough just to work now, because that's not how you get better at all. That's not really competitive, just to work. You have to learn as you go in every cycle. You have to do this iteratively. Now to do these things, we need to simplify how we do them. So we've changed our technology landscape to meet these goals, right? Some of these things you might notice. You might be familiar with. We've made infrastructure very cheap. We're making the process of releasing a non-issue. Everybody wants to create apps faster. And to do that, we automate as much as we can, as much as possible, so that we can release more frequently. But that's where the story starts to begin to change. We've raised the bar of expectations over what a great app looks like as a whole, as an industry. That also raises the requirements on maintenance and on releases. And on a good day, maybe this is manageable for you and your team. On a really bad day, we can put ourselves, our teams, and our brands at risk. So this goes for everybody, not just for small development teams getting started or enterprises looking to DevOps or to continuous delivery. The fact is, defects happen. They happen to a lot of people. They happen to some of the largest organizations and some of the most forward-thinking organizations. Take for instance, one of the world's most popular mobile apps for social. Last month, they released a version of their mobile app that crashed on versions of iOS. And this wasn't just an app crash. This was the entire operating system. It did a reboot. The device did a reboot because of something that wasn't tested on a portion of the market that was relevant enough where people actually started writing about it. So as we deliver more, we need to be conscious of this kind of risk. But who really is delivering more? That's the next question to ask, right? And what exactly does that mean? Earlier this year, this is one of my particular finds that I really like. Puppet Labs released their State of DevOps report. This is an annual thing. And so for the past couple of years, they've been showing different trends. And one of the things they found is that top performers, this year, top performers, meaning teams that release more than a few times a day, share a number of key aspects about how they deliver. They've made releasing a run rate motion, right? They have made managing change throughout the pipeline a non-issue. That helps them recover earlier and more quickly. Now they work in smaller batches, for instance. They don't take monolithic 3-month to 6-month, not even close windows of opportunity anymore. They go down into the weekly and semi-weekly releases. They carefully limit work in progress and team size. And all this results in dramatically shorter lead times from idea to release, as well as change failure rates, mean time to resolution. Now, all this stuff adds up to less unplanned work. Like, for instance, production downtime, putting out fires, I call them firefights, defects coming in because the quality wasn't verified beforehand, and now you're spending time on that instead of spending time on new functionality, building new functionality. What they're allowed to do now is spend time on innovative features, on process improvement, better planning. And so really, as it turns out, poor quality software causes a lot of unplanned work later on. Quality really impacts velocity. If your developers are busy patching defects from the last sprint, they're just not able to work on new stories that we committed to, right? Just like we learned as kids, before you run a race, you really need to tie your shoelaces tight. So in that case, how fast do you think Samsung at this point is shipping Galaxy Note tabs, right? Not very quickly anymore. The fact is, defects slow you down. But what leads to defects? Here are a few things. Let's just put them off right now. From what we want to go is from a place where there's things like unclear goals, right? Unclear goals, team misalignment, lack of important details or context on what should be built, technical debt, lack of attention to balancing new work while addressing that technical debt, lack of insight into why certain areas of your product are under like constant production defect firefights, and lack of visibility and measurement of risk before release. But once we start to turn the tide on defects, once we spend less time on defects and more time on features, we start to see very positive outcomes, things like higher App Store ratings, of course, but more bandwidth to make better decisions. And we start to feel more capable and confident that we're on the right track. So now what we have is a question that says, well, wait a second, how do we spend less time on defects or rework? Really, it's rework. Well, whether they're defects before release or reported in production, having to fix them is that rework, right? How do we spend less time on that? Well, industry data shows that the earlier you catch a defect in the development process, the less costly it is. Now, people are used to putting dollar values to this, but why not time? The fact is, from a time perspective, this is also very true. It's that you spend a lot less, whether it's time or money, upfront if you fix it earlier. If we're having to root around through multiple logs, right, without the full context of a problem we're trying to solve, that's another waste of time too, early on. So anything we can do to systematically connect the dots for the diagnostic process is going to dramatically benefit us in the end. Now, one of the things that I like is this quote from Kent Beck. This really reminds me that this is a relevant thing for all the teams involved, developers, quality engineers, product owners. He says, Kent Beck says, as an engineer, you should constantly work to make your feedback loops shorter in time and wider in scope. And so the way to do that is to catch those defects earlier on and foster feedback loops along the way. So to that end, and this is where we start to turn over to more of a demo-style approach, an example approach, we've got 5 tips that can help you detect issues earlier today. The first one is speak the same language, right? But we'll move through these as we go along. The first thing is to start with stuff that we can do right off the bat and then progress on that. So the first one is speak the same language. Now, what do I mean by speak the same language? Well, quite frankly, I don't mean the same language verbally, you know. It's great to have many different perspectives and many different ways to say the same thing. But in the meantime, I mean syntactical, literally down in the code. So for instance, if your app code is in one language, but your tests are in another, you're incurring cost. Think about it. The cost of constant context switching. It's harder for devs to help test engineers. It makes writing the test as part of the definition a little harder if you're having to employ multiple technologies to do that. So really what you want to do is reduce the difficulty of doing a thing so that it's a lot more likely to happen. And that's what I mean by using the same language. If your app code and your test code is written in the same language, there are some benefits there. It's not a mandate. It's simply just a recommendation that we see as a way that people are starting to move. So for instance, what it does is it helps you simplify collaboration on testing. It also helps you reuse code artifacts, things like variable names and element names as opposed to looking at paths. And in a moment, I'll turn that over to Nick. He can kind of show you what that's like. But it also makes code and tests equal citizens. It now elevates the code and the test and allows you to then contribute that into the same source code repository, which has all kinds of benefits like versioning and also making sure that things are checked in as part of a PR, for instance, a pull release, a pull request. So in that case, let's turn it over to Nick and see what this is like. So Nick, are you still with us now that I've been jabbering along?
Yeah. So here, let's jump over here. We're in Android Studio, and this is just a simple app that I put together. And all it does is light add notes. And so if we step over here, see on the left-hand side, we can step here into one of the activities. And you see all these different, r.id objects here. And then we step over back into the same, this is a test, also in Android Studio, and we have the same thing. We have the same r.id. This is what's allowing the objects to, be refactored together. This is one of the advantages you get when we talk about speaking the same language. In addition, now this is an espresso test, you'll see a kind of a pattern evolving here. You have an on view, and then you have a perform or a check. And this is really a opinionated pattern that Google's laid out, but it really simplifies the collaboration between a tester and a developer. Makes it easy for a developer to either write this themselves or to help a tester write the test out. And then the tightly coupled nature of this means that if an object is changed in code, it is then updated here in the test, and you don't have any any downtime or false negatives in your test code to have to worry about. So now that we've looked at kind of a couple of things in code, let's step out and take a look at what this looks like in practice. Now, I could have run this in Android Studio, but just in the effort of time, we'll run this on a device here in the cloud. So let me pull up an Android device here, and then I'm just going to use a REST call to do the same thing that Android Studio would. And this we'll start it now and point it to this device. So just like you would in Android Studio, this test will be packaged up and deployed to the device, both the app APK and the test APK getting installed into the device. And then here in just a second, you will see the test start to kick off. And so you'll see it run through a number of tests here. really quickly. There's in total 7 tests that were written, and looks like it's complete there. And so those 7 tests, we'll close that. I think they took about 14 seconds. And so the tightly coupled nature of these tests allow it to just execute so much faster, and of course, speaking the same language also allows it to be a lot more reliable. And so with that, we'll step back to you, Paul.
Yeah, so that kind of gets us to the point where we get to number 2 in our 5 steps, which is write stable tests, right? Well, it's easier said than done. I'm saying it now, but actually, it's entirely doable. People do this all the time. The people that we're on the call with do this all the time. It's not as hard as you think. We recently published a blog about this as well, so I encourage you to check that out on our blog. But if we actually step to the next one, the question is, how do you do that, right? How do you write stable tests? Well, the first one is you got to reduce some technical gaps in the object identification. That's just an obvious thing. So like we saw just now, there were variable names that we could reuse. Those were the actual names of the elements in the app, and those are the names that you would use in your test, but they're not strings. They're actual variable names. So when things are changed in the app, the test shows that. So be able to reduce those technical gaps between how you identify objects in your test and how they're identified in your app, that's a big step. The next step is, of course, clean setup and teardown procedures. So especially when you are in something like UI testing, you don't necessarily want to cut yourself off from the real world entirely, but you do want to make sure that you are minimizing what happens before and afterwards, and specifically that if you have to set something up, that you make sure that you tear it down as well. Now, the last 2 things here are just for me to, because I felt like this list of sort of suggestions, write stable tests, had to be complete, and I would be remiss if I didn't make a call out to the concept of hermetic tests. And so I would encourage you actually to go to Google and type in hermetic UI testing. Honestly, like I said before, you don't want to cut yourself off from the real world, but you do want those tests to help you isolate actionable faults without taking too long, and that's what that's about. And then the last one is, of course, soak testing, new tests before really checking them in. And this is simply just the performance people out there know what soak test means. Simply just means put your test through a couple of iterations, both locally and then maybe as a separate test suite before you include them in the larger test suite that might run as part of every build. That's an important part, is to prove the stability of the test before you move it in to the CI process or to build verification testing. So let's turn back over to Nick, and he's actually going to kind of show us what the first 2 bullet points are all about.
Yeah, so let's, I showed you an example in Android Studio. So here's another example in IntelliJ. So this would be an Appium example. Here, I'll expand out this project structure so you can see it as well. And this is very basic. But first, we have I wanted to show a bad example. The first thing that we talked about was reducing the technical gaps in object identification. So here, you'll see a really rigid XPath. Now, this is here on purpose. It's bad. I don't recommend doing it this way because if anything in the DOM changes, any button is added or another view is added, it could potentially break this test. And since you see this test is just this locator is just a string, that it has no context of the app at all. It's a separate code base from the app. So when looking at that, I realize that there's sometimes we have to locate by XPath or CSS locators or anything like that. What would be a lot better is down here we see an example of actually looking at the ID. So although it's still a string, at least it is the ID of an object, and as long as that ID doesn't change, this XPath would be a whole lot more stable. And then to take that kind of one step further, you know, what we should do here, and the reason that this is a part of the bad example, is we should abstract this out for reuse. And so you'll see the same locator here that will allow you to reuse that instead of having to type it each time. And so that's one part about just reducing the technical gap in object identification. And then we also have kind of a little bit better cleanup and tear down to help with this as well. And so you'll see in this bad example, I have my cleanup and tear down within my test class. And so if this test tests a certain piece of the app, and I need another test class to test another piece of the app, then I'm having to write this multiple times. And so a better way to do this would be to abstract out your test classes, as we see here, and then it allows, let's flip over to this better scenario, and then just extend this test class so that you can reuse it with every different test class, and then it allows you to not have to make changes, or if you do need to make changes, you're only doing it in one place.
So this is a little like almost like a page object model in the sense that the point is reusable code, right? That the stuff
Exactly.
that you sort of tuck into the base class is stuff that applies to every test or could apply equally to every test if you wanted to reuse it. I get it. That makes sense.
Yeah, we'll get into a little bit more of the code reuse with the next topic, but yeah, I think that's a good lead in. So with that, I'll pass it back to you, Paul.
Yeah. So now that we've seen that there are some things that you can actually do to simplify the technical gap by speaking the same language, and to create stable tests, that becomes really important. Stability around object identification, also stability in terms of how you reuse the code that is common to each of the tests. The next step is to actually break the monoliths apart. So that's another important aspect of catching defects earlier. It specifically facilitates test execution speed. The thing is, big ugly regression suites, we all know. We all have seen those. They take a lot of time. We often hear things like, they take days to run, or over the weekend. And if you think about that, having to wait for your regression suite to run for days and planning and creating your release cycle around that is kind of like an anti-pattern. In fact, it's actually like an anti-pattern. If you streamline your tests, however, even though you still need the safety net at the end, you're a lot less likely to have to capture defects in that last long safety net. So I just say big monoliths suck. Let's just put it this way. My API dev friends also have had this problem with their web services. The one solution that many of them are turning to is actually microservices. It's a way to break those monoliths apart. Breaking up the problem into manageable chunks is a standard computer science training mechanism. It's something that we all do. So the particular example here, and this is an anecdotal example, so your mileage may vary, just understand, this is an aggregate over some of the themes that we've heard from the way that people do this in the real world, is that the same goes for your regression suite, right? You got to break that up. You still have to run it, but instead of leaving all that dirty business to the end, you can catch defects earlier by breaking that regression suite apart. Now, everybody has different events during their development process. So in the job column of this table, it indicates that there are different things that happen at different times and at different intervals. Some things happen every time, for instance, code is put into a repository. And we might actually perform different types of tests and different amounts of testing to speed those feedback loops throughout this process to reduce the likelihood that we'll be stuck patching things up until the last minute. So like I said, it's an anecdotal example. Your mileage may vary, but some fast testing oftentimes happen every time the code is committed, and the average test times are just a basic example of what we're talking about. Unit tests that take less than 100 milliseconds by all means. Some API tests that are simply just requests and responses across the wire, those kind of things. But every hour, well, it starts to vary depending on what you want to do on every hour. Do you want to run all the regression tests? No. Most of the time, that's a no. In often cases, it's just the new tests that you're committing, or key smoke tests in the build verification process, BVT, build verification testing. Now, every couple of times during the day, you might also run all of your key smoke tests, your key functional tests, right? Some data, you might introduce some smaller data sets, but overnight, you might actually run all the data through the system. The point is you progress how much testing you do, and you do that less frequently, and that's the point. That gets you those fast feedback loops as early as possible. So now, every time code is checked in, it's done a significant portion of its basic testing, and it can move on to the next step. So from that perspective, I want to turn it over to Nick, and he'll kind of talk about how to facilitate that specifically in your tests and in Jenkins.
Yeah, so let's go back here to our Appium example in IntelliJ. And first, when we talk about monoliths, this test here is kind of bad in two ways. First, this is the 7 tests we saw run in Espresso are also here, and so it's just one long test case. And what we see a lot of times is when as teams have shifted into an agile methodology, shifting that shift left that we've kind of been talking about. They had a big stack of manual regression testing that had to be automated. If they were going to succeed, at all, it had to be automated. And so what happened was a developer or a dev tester went in and automated this just, as it was on the page. And this is what you end up with. And this isn't always the best way to break out those tests, like we were talking, to run certain smoke tests, to run just to break this up into smaller chunks, to give you early visibility to an issue. And so a better way first is to break this down into different tests, and you'll see a couple things come out of this. First, you're going to have a lot of duplicate code if you don't abstract out some helper methods like this to allow for that code reuse. So this will help speed up some of the development as well. And then secondly, let's scroll down here to an example here. Once you've broken out these tests, then you can start annotating each with a type of test that you want to execute. So in this example, it's a smoke test. So let's go over to Jenkins, and we'll take a look at this.
So what we've done there is annotate our tests, which basically means just tag them for different types, different times, and different types. Interesting.
Yeah. So this is just a simple Maven Jenkins job, and you'll see here we're passing in a different attributes here that we need to run on the Perfecto cloud, and then also passing in a default smoke test group, and then we'll exit. We're pulling in this from Git, and let me scroll down here, and then we're passing this in as a parameter so that it knows to run only that test. So let me step back, and then when I go to build this, you see I can change this, and if this is null, then it will run all the tests like a regression suite. Or if it has this, then we'll just run the one. And so we can step back here and let's take a look here. So you'll see this actually was a full regression that ran, but it gives you all the different steps as it run through the regression, and that's that's pretty much it. Breaking that up allows you to really hit a quick test and know the state of where you're at.
Very cool. Very cool. Can you switch back to those slides, the table again?
Yeah.
So one of the questions that just came in was QA doesn't control the Jenkins build servers. Development teams do. So how do we include more testing in every build? And the in every build is kind of the specific keyword. So consider this just sort of a pattern that we want to get to. And the next step is to actually talk about testing more in every build, right? So first thing I would say is to the question is that at some point it's the pain of the developer to have to deal with defects later on in the process. Context switching, when you've shipped that code, you move on to another thing, your mind's not in the same place. But, if you can get early feedback on every build, that's where the value is really there. And if you're in a situation where you've got separate teams for these things, or if you've got a couple of QA on a big dev team or whatnot, the fact is you got to find a metric that your team does care about, particularly the dev team cares about, and is really unhappy with. For instance, like I'm just thinking lead times, right? Or escape number of defects from one phase to the other. Code coverage is another example. So these metrics are what gets you in the door to say, hey, wait a minute, I thought these things were important. And then the next step is to actually reach out and get a conversation going with the right team members. Now, I would actually, for the developers and development managers on the call right now, I'd ask, are your QA in these conversations about how to speed up the release? And the release managers, for instance, do you align improvements to the impact that your releases have on App Store ratings? Do you actually make a connection for people to say, did we just improve something and did it have an actual impact on the customer, for instance? So connecting the dots for the people in the group, and especially for project management, helps you get more effective testing into things like definition of done. And now, everybody, we're on the same page about how to get more testing in every build. But when I say more testing in every build, what do I mean? Do I just mean what? More number of tests, right? So let's step back and say, well, once we have, we're speaking the same language, once we have some stable tests, and now that we've started to drive some feedback loops, things like critical smoke tests in our builds, and specifically ones that facilitate development cycles in a schedule like that, the next step is to improve coverage. So the thing is, fast feedback is only fast feedback. It has to also be better and accurate. And so better feedback comes from improved coverage in every build, more actionable coverage. And to that end, that's why Perfecto does what it does. We don't just need more test cases. For mobile and web, that also means platforms and coverage too. So which platforms, you might ask? Well, again, that depends on your own audience. The thing is, though, your marketing teams and your analytics, your ops teams, they might use this data, and you can definitely use it too, specifically around how to prioritize tests. Now, we publish this thing called the Digital Test Coverage Index every quarter. Every single quarter, we update this so that you can have a conversation with your group, both internally, maybe even externally, and a conversation about which devices and browsers you should prioritize. Now, to me, that's tangible business process alignment. That's getting the right people in the right room to make the decisions on what's the most effective thing to automate and then to put as part of every build. And so just like reliable execution comes from stable tests and testing environments, the next step is to think about fast execution. And fast execution doesn't just come from something like Espresso or a slightly faster testing framework. It also comes from prioritization of tests and parallel test execution. So in this case, that's what I mean by more. So let's actually see what that kind of looks like. And Nick, you have something set up for us, right?
Yeah, yeah. So let's go back. We'll go back here into our Appium example, and the testing more in every build, kind of like Paul mentioned, is twofold. First, if we're limited in a time box, you only have so long to run your test. Then I'm assuming that you've optimized to get the core functionality tested at the right points. And then where we can expand on that is, and you'll see it here, is running in parallel across multiple devices. Because you have different resolutions, and especially becoming more with iOS, but especially with Android is the fragmentation across these devices, OS carrier combinations, where every carrier and manufacturer has their own variant of the operating system. These are things that you want to test, and that if you're not testing them now, you're likely getting some bad reviews from these. And so it's essential that the way that we're helping this process is by allowing you to test all of these in parallel across the devices and operating system combinations that are important to you. And so this is how we do that using TestNG. I'm passing in a couple parameters here, and so that we can run this in parallel. And so let's just kick this off. I'll pull up our dashboard so you can see it in action. All right, and just go ahead and kick this off.
Mm-hmm.
And you're seeing it launch on these two devices right now. It's a Galaxy S7 and a Nexus 9 tablet.
I see. I see. The same app,
so,
the same Android app. I gotcha.
Same Android app, and we're just going to run it here in parallel. So instead of it taking 13 minutes to run on one device, and then we have to connect to another device to take the same amount of time, we're limited by how long the test suite takes to run, not how long it takes to run across every device that you have. Mm-hmm. So this brings me to another point. Let me close this so I can show you really quick. Is not only testing across different device and OS combinations, but also adding in real end user conditions. And this is really where you get the most bang for your buck. And we'll show it more here in the reporting aspect in a minute. But adding in these, we've labeled them personas, but it's just a set of predetermined end user conditions that really give you a feel for. You guys have an understanding of who your end users are, and maybe they're running Instagram and Facebook in the background, or maybe they're jumping between network and Wi-Fi. There's a host of end user conditions that allowing you to test that in parallel as you're running these tests really allows you to test so much more in every build than you ever could before. So with that, I know we're just in the effort of time. I'll let you get back to it, Paul.
Yeah, and that brings us to that last point that we had, which the fifth point here is to provide context with the results of your tests. So whether your tests are these sort of one-off exploratory tests, whether they're tests that are running in CI, and especially when they're running in CI, it, it doesn't just mean that there's feedback loops. All the feedback loops everywhere, that turns out to be a lot of results, which means a lot of data. And so that's kind of meaningless without context. And that's why I mean what we need to do is provide context with results. Think about how many hours a week we spend sifting through logs, right? Context over the data in those logs matters. Being able to have a reproducible result is far easier when the context of the test execution is not only available, but simplified and easy to communicate. So remember those tests that we ran before? That's what Nick was referring to. That's what we're going to see here.
Yeah. So here I'll just take it back here, and let's go back to Jenkins here. So this same test, and you can see there's multiple steps here because it did for each Android device. But you'll see this is normally what you think of when you think of reporting, and this is what Paul was talking about, that spending so much time, hours sifting through logs to figure out what happened, and so in your standard Jenkins setup, what we've done here is I just printed out a link to the report. And so we'll click on that, and I'll log in here. And so for this particular run, you see a view of what happened. Now, in this case, all 6 tests passed. That's not always very helpful, but it's good to know. And you see the different here on the left with the class names, the different things that happen. If I go back, let's go back just the last week and look at everything that failed and passed. All right. So you see here in the last week we have a high level view of the number of tests. There's 87 tests that ran. 8 of them failed. And then we also see kind of a historical view of what happened in the last few months, broken down by date ranges here. And then below that here, we have a list of all the tests and what happened there. So let's just dive in to one of these. So we had this broad view, and then now we're narrowing it, kind of as we go. And so this reporting aspect shows you all the different steps that happened as part of the test, and then it also has video playback. Let me go back and find one that failed so we can also see what happened here. And so if there's a failure, it will show you the stat trace here of what happened. And in this case, it looks like you can see here the ID was wrong. And so let me go back here. And to take it one step deeper, and this is kind of what we were talking about with setting up these end user conditions. We have here what we call a persona as Sarah. So this is somebody that you may feel like makes up a big portion of your app users, or this could be customized as well. But running WhatsApp, Waze, Cookbook app, Amazon, Facebook, and has generally good network. Also lives in California. So all these things are bundled together in code using that persona to be able to test exactly what your target users are. And then you get a lot of good information here about what the memory usage was, what the network in and out was, as well as here the CPU. So we can see here when the app launched, it was a really big drain on the memory, and then kind of as we go along, different spikes as different actions are going on. Immensely helpful to provide this quick feedback so that you can, really speed up the whole development cycle and get a good product out.
Mm-hmm. Mm-hmm. And so a lot of this information is is really only helpful if you have that context. You have an easy shareable thing that you can collaborate, and that's what we saw with those URLs from whether it's a URL from Jenkins or you just copy that and paste it into an email. Now all of a sudden somebody who's caught a defect, whether that's a dev can share it with another dev, or somebody in QA can share it with devs. The point is the feedback loop itself, the time that it takes to go from one phase to another, is dramatically smaller when you've got this kind of a analytic platform here.
Yeah, and Paul, that was a good point. You and I were in a meeting last week where we had a customer that was saying they're doing this exact same thing, and the Jenkins job is actually integrated with their Slack channel. So if there's a failure, they get a link to the failure that shows them all of that, and it's dramatically increased the speed at which they can deliver quality features.
And that's the thing, is that if that's kind of a goal, if you really want to drive acceleration in your dev teams and your quality assurance and your testing processes, you have to have some basic things set up. And that's why we've provided these 5 steps to detecting issues earlier. Think about it. Get on the same path, get on the same language, write some stable tests, break your monoliths up, start to test more in every build, and then provide context with results. That's a tangible path to be able to, instead of just talking about shift left with management, to actually do it as part of your process and kind of show them the impact of this stuff. So there's been 1 or 2 questions as we've gone along, and I'm going to flip over to that view so that I can read 1 or 2 of them off. Dave says, what devices were you using today? Were those emulators? And no. Those are real devices in our data center. Nick only had a few for demo purposes on his demo account, but really the private cloud, you can have as many options as you want. So that goes for things like Apple Safari too. So we're not just talking about real mobile devices, we're also talking about real web browsers for mobile browsing too. Another question here, are there resources you can point to for Android testing with Espresso? Yes. Well, that's part of my research here that I do as part of my developer evangelist role. So a couple of things come to mind. One is, of course, the Google testing blog. You can't talk about Espresso without talking about how they set this up for you. And they talk about stable tests as well, and they give some recommendations on that. Their documentation is pretty awesome. I would also suggest Big Nerd Ranch, a number of books there. They have books on Android, particularly Bill Phillips and his crew. Also things like Big Android Barbecue, events like that. Oh man, they've got a lot of YouTube videos that you should definitely check out, specifically Chuki Chan is her name, and she has some great videos about Espresso on YouTube. Other events like AndDevCon, I'm speaking there at the end of this month. And then also, you know what? Actually, what I'm going to do is I'm just going to tweet out a link to this shortly after. So check out that hashtag on Twitter. The hashtag is #BeyondShiftLeft. So you'll be able to see that link that I shoot out later on, and that gives you access to kind of my pocket of research there. Last question here. What does hermetic mean for UI tests? Well, since we only have 1 or 2 more minutes, I guess the short answer to that is, think about it like a hermetic test is essentially, it only has access to the resources that you've declared directly as dependencies. So in Espresso, that might mean that you actually want to check out something called intents. It's a way to explicitly specify what you want from the operating system. I'm just thinking setup and teardown procedures. Hermetic tests when it comes to setup and teardown, that would be like rollbacks and reconciliations in data stores. So if you know you're going to do a bunch of data work, but you don't necessarily want to incur that long term, or if you need to compensate for that, you would do transactions either afterwards, like a rollback or something like that. Certainly things like closing connections, right? And then file I/O. If you do any file I/O, you just want to make sure that you clean that up afterwards. So the rest of the questions, just being respectful of time, the rest of the questions we're going to answer individually, and we'll shoot you out an email to that. I really do appreciate your feedback there and your input there. And the last thing I'd like to do is thank Nick Sunhinas, once again, system engineer from Perfecto, and as well Perfecto and TechWell for sponsoring this event. And I thank you all for being part of it as well. Keep the questions flowing, and we'll see you next time.
Thanks, guys.